Hi everyone, welcome to discussion 3 of Data 100. Today I'll be talking about some data cleaning in EDA as well as some regular expressions. Now, last week I got some feedback that the resolution quality wasn't high. So this time I'm trying to zoom in to my iPad and trying to get better resolution for you. But if this does not work, please give me feedback on the weekly survey that we post. So let's get started with the first section of this worksheet. So we will be working with the baby names data set again, as you must be familiar with from lecture. And the first question is asking us to consider the variables name, year, and count. So, and you are asked to talk about what kind of variable each of them are. So let's talk about, before we talk about the variable, before we answer the question, let's first talk about this visual that I have here. So here you see that you have a general, you have the variables, and then you can go down this tree to decide which category they belong to. So the variable type. So for the first decision you need to make is whether that variable is quantitative or qualitative. Now, usually this is straightforward, but sometimes there are some blurry cases. But a key method that you can use to make that distinction is whether that variable has meaningful intervals. Whether essentially you need to ask whether the difference between two values remains the same. So we're going to explore that in the first part, but that's something that you should keep in mind. And the second part is subcategories. So within quantitative, you have two categories where you're discrete, which is just whole number values, and continuous, which is where you can have decimal points, or it doesn't have to be an exact whole number value. Second, so within qualitative, you can have nominal, where there's no kind of order in the qualitative variable, and ordinal, which has some kind of order in the qualitative variable. So let's actually put this into practice so that it's you can learn this better. So let's look at the name variable first. Now, which of these types would name belong to? So the answer for this one is actually nominal. So again, name is just a word. So there's no concept of having a difference between the name. So therefore, you would go down this path, and then since there's no order between two names, we will go down this path, and then that's gives you name is nominal. Now let's talk about year. Year is year is a number, and here, if in the context of this data set, the difference between 1910 and 1911 is the same as the difference between 1911 and 1912. It's just 1 year. So therefore, the intervals themselves are meaningful. Therefore, you would go down this route, and then after that, you'll notice that since year is only whole number values, it's going to be quantitative discrete. So let me quickly write that down. Similarly, for count is also discrete. So let me just write that down and let me explain while you think about why for a minute. But essentially, count is also a number where the intervals are meaningful. In this case, the count represents the count of baby name. We'll talk about what the count actually means in the next part, but essentially the difference is the same. But the difference between 294 and 295 and 295 and 296 is the same. So it's quantitative, and it's also discrete because it's just whole number values. So that's part A. Now moving to part B, which of the following is a primary key for the baby names table from question 1? Before we answer this question, again, let's talk about what a primary key is. So as defined here, conveniently for us, a primary key is a column or a minimal set of columns that uniquely determines the values in all the remaining columns. So now, in other words, a primary key tells you about the granularity of the data set. So let's look at the baby names data set again and think about what does each row mean. And here's a thought experiment before you actually answer this question, okay? So I want you to look at each of these columns and remove a column and see what happens to the row. So for instance, let's remove the year column. Let's remove the year column and think about what happens. Uh, Now if you think about it a little bit, you'll see that you can have Mary as a name, Mary, who was a female in California in 1910, 1911, and so on. So essentially, you can have these three things common across this, and there's going to be definitely rows with those three combinations. You might argue that the count might be different, uh, but it doesn't have to be. It can be the same. So what you'll realize is that the count column actually loses meaning. This column loses meaning. And that's because there's multiple different multiple rows with the same combination of California, female, and Mary. So what does the 295 then mean? Because of those multiple rows. So you now, based on this analysis, you'll finally come to the realization that year is an important column to have. It is part of the primary key. And so is state. So is state, so is sex, so is year. So these four columns are the reason the count column itself has meaning. So essentially, so the correct answer for this question is D. And another way you can think about is that the primary key is basically where the unique combinations of the columns involved in the primary key give meaning to each row. Okay, so essentially, the primary key has a unique combination every row. There's not a single repetition. So that is part B. Okay, so let's go to question 2. Question 2 is about dealing with missing data. Now, this is a very common thing that you're going to run into as a data scientist. So let's get in practice with that. So here you're exploring in the Berkeley dataset, and it has 1 million records. And you'll realize that a portion of these measurements in different fields are actually NaN values. And you're thinking about imputing these missing values before continuing, but you just what you want to make sure you want to like understand how you want to solve this missing data problem. So let's talk about each part separately. So in the first part, you're given this figure where you have inches of rain on the y-axis and cups of coffee sold at V&A Cafe on the x-axis. And the question is asking you that 30% of the data set is missing. What do you do? What would be the most effective way to solve this issue of missing data? Now, what you should realize is that 30% of data that is missing is in the inches of rain column. That means we have data about cups of coffee as sold at V&A Cafe, but we don't have the data for inches of rain. So again, there's multiple ways you can do this. The first thing that you should always do here is to create a distribution of the variable that has some missing data. So for example, I think so this looks like a roughly symmetrical distribution. So I'm just going to draw Gaussian kind of thing here, center at 10. You can be more systematic, and because you have access to data, you can actually draw the Gaussian as a data scientist. But here I'm just going to approximate it as a Gaussian. And you'll notice that the Gaussian has this very nice property where the mean, let me just write it down here. So here, the mean is approximately equal to median, which is approximately equal to the mode. So in this case, A, B, and C work to impute the missing values. Um, Option D is incorrect because a huge chunk of a data set is um, missing. 30% of a data set is missing. Now, if we drop those rows, uh, we will also lose information about cups of coffee sold at Vienna Cafe. Now, that information is still valid information, and we don't want to introduce some kind of bias in that data analysis. Therefore, we don't want to drop this data, drop any rows of missing values. Another approach you could try is imputing missing values. Now, you can impute because you have data about cups of coffee sold. So, for example, let's say you want to, let's say for one of the missing values, you know that there were 20 cups sold, 20 cups, but you don't know how many inches of rain happened for that particular data point. So what you can do is you can look at all the data between 19 and 21, and once you look at this data set, once you look at the data, you can calculate the average of all the data points and calculate the average inches of rain in that range, and you can assign that value to the 20 cups data point. So that is how imputation works, very roughly speaking, and that would be a good way to go about this problem as well. Okay, so let's look at another distribution. So here we are examining the amount of money lost or gained in a game of poker, and in this case we are missing 1% of the values. So which of the following techniques would be reasonably effective in solving this issue of missing data? Now, if you notice, this is a bimodal distribution. And since this is symmetric, you'll notice that the mean and median are here. So this is the mean and median. However, these are the modes. This is mode 1, mode 2. So essentially, if we use the mean to impute the missing values, we will get a distribution like this. And this thing over here is a bump which we do not expect from the internal data frame. Now, our goal, again, just to repeat our goal is to maintain the distribution of the data set, not change it. And this third peak carries a lot of meaning with it. And in this case, therefore, it's not valid. So we cannot do A, we cannot do C. However, we can do B. Now you might ask, should we do 0 or should we do 100? The answer is that it really depends, and that's something that you need to choose as a data scientist. Maybe you do both. However, either would work here because both of these have high frequency of data set. Therefore, yeah. D actually in this case also works, and the reason for that is that we have very few missing values. Just 1% of our values are missing. So it's completely fine to drop these rows. E, on the other hand, does not work, and the reason for that is that because you can only impute when there are two variables involved. Here, there is only one variable involved. We have density on the y-axis, not any variable, and therefore we cannot impute. All right, so moving to C. So C, you'll see in part C, you have the extra credit score on the y-axis, and you have the hours slept on the x-axis, and you're told that 0.5% of extra credit score is missing. So here, the missing NaN values are replaced with an impossible score of negative 0.002, and this makes the graph look very funky. So which of the following techniques are, again, most effective in solving this issue of missing data? You'll notice that this distribution is not really symmetric. It has 3 peaks, and so it's really hard to tell. It's hard to if we use a mean, mode, or median, I think it's arguable that you might bias data in a certain way. Um, so one approach you can do is just drop the rows. It's just 0.5% of your data set, which is completely fine to drop. Again, it depends on how big your data set is. In this case, it seems like a small value. Um, um, and for part E, you can also impute because the missing data is only for the extra credit score column, not R slept. So you can again use the R slept data to impute values in the given range. So getting the intuition for this analysis in EDA would really would take some time. But the more important point is that missing data is part of data science. Dealing with missing data is part of data science, and so you should be able to argue for why and how you're dealing with missing data.
Today we're going to be going over the Fall 2022 Data 100 midterm. So let's start with question number 1. It's the annual Monopoly World Championship. The finalists, Sean, Amanda, Neil, and Annie, are playing Monopoly, a board game where players pay a price to buy properties, which can then generate income for them. Each property can be owned by only one player at a time. At the end of the game, the player with the most money wins. Sean wants to figure out which properties are most worth buying. He creates a data frame income with data on the current game state shown on the left. He also finds the data frame properties with data on Monopoly properties shown on the right. Both tables have 28 rows, but only the first few rows of each data frame are shown. Okay, and then we have some information on each of the columns, which you should definitely read, but I'm going to skip over that for now. And it says, note, for properties that are not currently owned by any player, the player and income generated columns in the income table have a NaN value. So we can see, for example, row 3, no one owns Kentucky Avenue yet, so the values for the player and income generated column are both NaN. Okay, so let's do part A. What is the granularity of the income table? So granularity is asking us, what does each row represent in the context of our data frame? So if we look more closely at our income data frame, we see that we have 3 columns: player, property, and income generated. So let's just read through what every column represents. For player, it's the name of the player. For property, it's a property currently owned by the player. And for income generated, it's the amount of income a player has earned from that property so far. So just reading through these 3 columns, I sort of think that these 3 columns all relate to one property. Because for the first column, player, it tells us who owns that property. And then for property, the column itself, it tells us the name of the property. And then for the column income generated, it tells us the amount of income a player has earned from that property. So for part A, the answer would just be property, because every row in the income table represents one property. Okay, moving on to part B. Which of the following lines of code successfully returns a series with the number of properties each player owns? Okay, so we want to find the number of players each player owns, and that should be returned in the series. So let's go through the options one by one. So the first one, income.group by player, and then we're aggregating it with the value counts function. So for this one, just reading through it, I can see that it's wrong, because when we do group by and then we're aggregating, if we don't do anything after and we're not selecting any specific columns, this is just going to return a data frame. And this pd.valueCounts function will have been applied to every column in our original data frame. What we want here is to return a series with the number of properties each player owns. And again, a data frame is not the same thing as a series, so option 1 is wrong. Then for option 2, we're selecting the player column from the income data frame, and then we're using .valueCounts. So if you refer to the Fall 2022 midterm reference sheet, value counts, if you find it on the sheet, is a function, and it returns the number of times each unique value appears in a series. And this is exactly what we want, because we're trying to find the number of times that each unique name appears in our income data frame. So the option 2 is correct. Then moving on to option 3, we're doing income and then we're trying to select both the player and property columns. This is incorrect because this is incorrect syntax. If you want to try to select multiple columns from a data frame using the bracket notation, you have to do double brackets. So it can't just be one bracket. If you're only using one bracket, there should only be one column inside those brackets, and doing something, for example, like income player will return a series, where income and then selecting player and property will return a data frame where you have two columns, player and property. So option 3 is incorrect. And then we have option 4, income.group by, so we're grouping by the player column, and then using the .size function. And if we look at the reference sheet again and find the .size function, it says that it returns a series containing the size of each group, including missing values. And this is, again, exactly what we want, because we want to count the number of times that each name appears in our income data frame. So we basically want to count the size of every single mini data frame that's generated by this group by, because when we group by players, we're going to end up getting a bunch of mini data frames that have the same player name. So for example, this one would be Sean and all the properties that is owned by Sean. That's a one mini data frame. And another one would be, let's say, Amanda, and then all the properties that Amanda owns. And we want to find the size of each of these mini data frames because it corresponds to the number of properties that each player owns. And .size will return exactly that. So option 4 is also correct. Okay, so moving on to part C. He now decides to calculate the amount of profit from each property. He wants to store this in a column called profit in the income data frame. So for part I, to do this, he first has to transform the income generated column to be of a float data type. Write one line of code to replace the old column with a new column, also called income generated, with the data type modification described above. You may assume that each entry in income generated consists of a $, followed by a number except for the NaN values. Okay, so for this question, we're doing two things. One is we are replacing the old column with a new column, and then for the new column, we want to transform our original column to be of a float data type. Because if we look at the income generated column, it says here that it's actually a string. So these are strings, not float values, and we want float values. Okay, and we also only want to select the number itself, so we don't want this $sign here. Okay, so the first step is that we want to replace our old column with a new column, and we can do that using some syntax. So I'm going to write down the income data frame, and then the new column that we want to add is also called income generated. And this will basically replace our old income generated column. And now we want to transform the old income generated column into a float. So the first thing that we want to do is just select the old income generated column. And before we can convert it to a float, we want to get rid of the $sign at the front because it tells us that each entry in income generated consists of a $sign followed by a number. So it's going to look like something like this, a $sign followed by some numbers here. And we only want to keep these numbers and we don't want this $sign here. So we can do some string manipulation. And in order to select everything starting from the first index, because this $sign corresponds to index 0 and this 1 corresponds to index 1 and so on, we can go ahead and just select everything starting from index 1 and beyond. So now we have basically just everything excluding the $sign, but we still need to convert it to a float type. So one function that you can use is the dot as type. And what type do you want to convert it to? It's float. So we can just write float inside the parentheses. So this would be the final answer. Okay, so moving on to part 2 of C. Assuming that the answer to the last subpart is correct, let's add a profit column to the income data frame. Fill in the following blanks to do this, and please add arguments to function calls as you see appropriate. And note, profit is calculated by subtracting the purchase price from generated income. So we want to add a profit column to our income data frame. And it says here, profit is calculated by subtracting purchase price from generated income. So I'm just going to write down that profit is equal to generated income minus purchase price. Okay, so let's see how we can do that, how we can relate generated income to purchase price. So if we look at our two data frames here, let's just look at the income one. So we see that we have income generated, but we don't have purchase price because purchase price is in the properties data frame. So this means that we're going to somehow have to merge these two data frames together in order to get both the income generated and purchase price columns. And in order to merge on two data frames, we need some sort of common column that we can merge on both data frames together. And right away I noticed that both data frames have this property column, and this means that the property columns are the same in both tables, so we can use that to merge the two tables together. So let's go back down. So here there's some pseudocode that's given to us, and if we just look at the first line, we're doing income dot something, and to me it feels like we're trying to, again, we want to merge the two data frames together, so we're probably using the merge function, which I'll write down for blank A. And if you look at the reference sheet again, for the merge function, it's something like the left data frame dot merge, the right data frame, and then the column that we want to merge on for the left data frame, and then the column that we want to merge on for the right data frame. So what goes in blank B is everything that is inside these parentheses. So let's just fill out these parameters. So the data frame that we want to merge with income on the right is just the properties data frame. Okay, and then what column do we want to merge on for the left data frame? That's just the property column. And what column do we want to merge on for the right data frame? That's also the property column. Okay, so this would be the solution for blank B. And some simplification that you can do is that when you are merging two data frames that have the same, and you're merging on the same column name for both, like for example property and property, you don't have to write out both of the column names. You can just write it out once, so it can just be properties and then property, and then this parameter is just called on. Okay, so moving on to blank C. So this is when we can actually calculate the profit column. So this is the second line here, and we know that profit is equal to, again, generated income minus purchase price. So let's just go ahead and select these two columns, and we're selecting it from our new data frame that we just collected, which is called combined DF. So I'm just going to go ahead and write combined DF, and I want to select the income generated column, and then subtract from that the purchase price column. Okay, so moving on to part D, regardless of the answer to the previous subpart, assume we've successfully created the profit column. Let's help Sean see how well he's doing by finding the average profit he's made on the properties he owns. Which of the following lines of code does this? Okay, so we want to basically find the average profit that Sean has made on all his properties, so we should be returning some sort of number at the very end. So let's look at all our options one by one. For the first option, we're grouping by players, selecting Sean, doing aggregation. So option 1 is incorrect because after we group by player, there is no column called Sean. Sean is a value inside the player column. Sean is not the name of a column itself in the income data frame, so option 1 is incorrect. Then for option 2, we are again selecting from the income data frame, and we have a conditional inside the brackets, and this conditional is checking to see if the value inside the player column is equal to Sean. So if the value inside the player column for a row is Sean, then this will be true. Otherwise, it will be false. And after we get a bunch of, let's say, true falses, and so on, this bracket notation will only keep the rows that ended up with true for a conditional value. So it's going to cross out all the rows where the player name is not equal to Sean. So after this part, we basically have a data frame where we only have rows that have the player name Sean, which is what we want. And then we're selecting the profit column and then using the mean function on the profit column, and that will calculate the mean of all of the profits for the properties that Sean owns. And that's exactly what we want. So option 2 is correct. Then for option 3, this is pretty similar to option 2, except we're using the dot lock notation. And this part before the first comma refers to the rows that we want, and then everything after the first comma, so this profit, refers to the columns that we want. So in this case, again, we're using n comma player is equal to Sean. So we're checking to see if the value in the player column is equal to Sean. If it is, it's going to be true. If not, it's going to be false. And then we're only going to keep the rows that are true, so we're only keeping rows where the player value is Sean. Then we're selecting the profit column. So this is going to end up looking something like this, where our player is Sean, and then all of the properties he owns. And then we have the profit column. And then it's the profit for all the properties that he owns. And then we're calling the mean on the profit column, and it's going to give us the mean of the profit of all the properties that Sean owns, which is, again, what we want. So option 3 is correct. And then for option 4, this is the same thing as option 3, except we're using iLock. But iLock is wrong because for iLock, we want to pass in indices to filter on and not labels. And here we're passing in labels. So this is incorrect. Okay, moving on to part E. So John realizes he's lost more money than he's made. To solve this problem, he begins by writing some pandas code to merge the property color column into the income data frame and drops all rows of NaN values. He calls this data frame merge_df, and shown below are the first few rows. Sean decides he will now only buy properties from a color group that he deems profitable. He deems a color group profitable if at least 50% of the properties in the group that are currently owned by players have made a positive or non-zero profit for those players. So fill in the following lines of code to help him display a data frame with a subset of the rows in merge_df. The rows with properties that belong to profitable color groups. Your solution may use fewer lines of code than we provide. Okay, so this problem seems a little extensive, so let's break it down. So what we want to do is figure out all of the profitable color groups. And a color group is deemed as profitable if at least 50% of the properties in the group have made a positive or non-zero profit. So, for example, if this is our entire data frame, which is not, but let's just say it is, we would be grouping together all the light colors, so dark blue and dark blue, and then just yellow, green, light blue, and purple. And then from here, we want to see if each of these color groups are profitable. And the way we do that is we find, we want to see how many profitable properties there were for each color, and then we want to divide it basically by the number of total properties in that group. So sorry, that was a little confusing, but we can look at dark blue as an example. So for the first dark blue property, the profit was negative. So this was not profitable, so I'm just going to say false. And then for the second dark blue property, this was profitable because it's a positive value and greater than 0. So this will be true. So we had a total of 1 profitable property, and we had a total of 2 properties just in total. So our total percentage of profitable properties in this case is 50%. Because the 1, or the numerator, corresponds to the number of profitable properties we had, and the denominator, or the 2, corresponds to the total number of properties that we had. So we can do this to calculate the percentage of properties that are profitable for each color group. In this case, for dark blue is 50%, so dark blue would be considered profitable because it's at least 50%. Okay, so in order to do this in code, something that is helpful or something that I think that should immediately come to mind is the group by function, because we want to group by all of the different property colors and we want to put like property colors together. So here I'm just going to say we're using group by, and what do we want to group by? We want to group by the property color. And then we only want to keep the rows that correspond to the same property colors that are profitable. So we would either be keeping all the property colors with dark blue, or we would be excluding all the property colors with dark blue. So for every single color, we want to decide if we want to keep the rows of that color or discard them. And we only want to keep the rows that have a color if that color is profitable. So whenever we're doing something such as wanting to discard like a subset of rows in a data frame that have a similar value in a column, you want to immediately think of using filter. Because what filter does is after we group by, let's say in this case, property color, we're going to get a bunch of mini data frames with the same property color. So dark blues will be in this mini data frame, and then we'll get another one that's with yellows, and another one that's with green. And then for each of the mini data frames, we're checking to see if we want to either keep it, and it's going to be in our resulting data frame, or we want to get rid of it. And we want to keep it in this case if, let's say, dark blue is profitable, and if dark blue is not profitable, we get rid of it. So inside our filter function, we want to pass in some sort of function that we want to call on each of our mini data frames. And if we look at our pseudocode, this function is kind of already defined for us, or the function header. So we can just pass in func. And now we want to fill out what the actual filtering function is. So again, what we want to calculate is the percentage of properties in every single color group that is profitable. And what we can do that, and how we can do that, is again to calculate the percentage, and on the numerator is the total number of profitable properties, and on the denominator it's the total number of properties. And this just refers to one color group, and this, whatever this percentage turns out to be, it should be greater than or equal to 0.5 in order to be kept in our resulting data frame. So how can we get the number of profitable properties? Well, we can first check to see if a property is profitable at all. So the way we can do that is to select the profit column, and group in this case comes from this group here, which refers to every mini data frame that we're passing in. So we're selecting the profit column from the mini data frame that we're now referencing, and the profit should be greater than 0, because if it's greater than 0, then we know it's profitable. If it's not greater than 0, then it's not profitable. So this will return a series of a bunch of true-false values, and we want to find a way to basically convert these true-false values into a number. I'll just write down like a number, an integer, that tells us how many profitable properties there were, or how many properties had a profit greater than 0. So we're basically trying to sum the number of trues that we get in our resulting series. And there's actually a function that we can use to sum up the number of trues, and that's the sum function. Because sum will sum up all of the trues in our series, because the trues will be converted to 1, and the falses will be converted to 0 when we're summing them up. So in this case, we're just summing up all the ones, and the ones in this case correspond to the number of true, and trues correspond to a profit or a property having a profit greater than 0. Okay, so now we have the numerator, so let's look at the denominator. So you get the total number of properties. This part is a little simpler than a numerator. We can again just select the profit column and count how many total entries there are in our profit column, because every entry corresponds to a row in our mini data frames, and we're trying to see how many total rows or properties we have in each mini data frame. So we can use the len function. Okay, so now that we have the percentage calculation figured out, let's convert this into code. So first you want to check to see if the percentage is greater than or equal to 0.5. So we can just write down what we wrote here. So the numerator is summing up the series of true falses, where true is if the profit is greater than 0, And then we want to divide this by the total number of properties that we have in each mini data frame. And we do that using the lane function. Okay, and then we want to check to see if this is greater than or equal to 0.5. So if it is, this means that we want to keep all of the rows that correspond to that color. So we can go ahead and return true. And once the filter sees that the function return true, it's going to keep all of the rows in that mini data frame. Otherwise, we want to return false. And this will cause the filter function to filter out all of the rows in that mini data frame because the color group was not profitable. Okay, and this concludes the walkthrough for question 1.